like load, and I was like,
Today I'd like to talk a little bit about rotating objects on the screen and moving them around, moving them up and down, back and forth. This is something that's commonly not done in web pages because we have another technique for doing it, which I'll show you in the next couple of weeks. But it is possible to actually move stuff right on the web page itself. Usually what they do is they call in a program called Canvas, which is part of HTML. They bring it in and they lay it over the screen, and then you can do all kinds of animations or whatever you want. There's all kinds of possibilities, okay? But the normal screen itself, where you see pictures and buttons and all that, you normally don't see a lot of animation here because it's just hard to do. It's easy to do with JavaScript, but not really write JavaScript, so they don't get to see the access to those unusual things. So today what I want to do is I want to cover two things. I want to cover rotation, how you take an object and put it on the screen, picture, anything, and make it rotate any way you want, and how to make it move around so you can move it any way while the program's running, keep it moving. Okay, so you sort of can animate things. When you think about it, when you talk about animation, moving things around, when you talk about rotating, you also have these z-indexes of depth. So it's possible to put things behind each other and cause things to happen with animation and depth that you couldn't normally have happen. In other words, two objects, well, you can see through the first one a little bit and see the second one. So you can do stuff and you can cause effects to happen on the screen just by simply having the capacity to rotate or to move and to have depth to it at the same time and to have transparency. So you have a lot of things you can do. And once you start putting those things together, you'll see the possibilities of many. First program I want to do is one that I didn't get to last time, and it kind of explains how animation is done. Even though this is just a rotation, it's a very simple rotation. By the way, you can access it immediately. You go to cog.html. It'll run for you right here on the screen. So it's just a simple rotation type. So obviously the best thing to do if you're going to use rotation is get the simplest program, see what the basics are, and then doctor it up later when you want to make it more, more involved. So the program looks like this. Look. It looks like that. These things die. Try a second. Much better. Here's what we're going to do. Here's a picture of the screen. And there's a gear here. It looks something like this. I'm kind of rough it a little bit. A little gear. And all that gear is going to do is just roll. It's just going to spin, that's all. Nothing else. And that's all we want it to do. We just want that gear. When the program starts, you just see this gear and sort of spinning around. Okay. And the gear actually is just a drawing I made or got someplace. And except for the hard part that you see here, the actual gear itself, everything else, like around it, of course, it's an image, but the image is transparent. I brought it to XView and made that all transparent. So the only thing you can actually see is the gear itself. So if it was on top of anything, you'd see the gear spin. The frame wouldn't be with it, which would cause trouble. Okay, so starting off, I'm saying JavaScript here, and I'm going to have a function that's going to do this job for me. It's going to spin for me, and I gave it the name rotate animation. you don't send anything up to it. What we're going to do is when the body loads, we're just going to onload go to it and stop making it do its thing, okay? So immediately this function is going to start automatically as soon as the program loads. It's going to start working. Okay. Let me write this part over here, the body part. And on load, I'm going to go to that function right there. Start the thing. Just start from the middle, okay? Right there. Oops. Oops, 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 oops. See that right? That's rotate animation. It says the same thing as this right here. Okay, so in other words, as soon as the program all loads, it jumps to the body and it says immediately start running that function. That's what it does. Okay, and also in the body, I have an image. I have to have the image of the wheel, of course. And it looks like this. I said image, source tools, and in this case, I call this thing cog, cog.png. That's the picture. That's that picture of that right there, cog.png. And the ID of this thing is equal to, I gave it the name image 1, like so. That's it. So in other words, what I do is I have this picture, a paint called cog, and I simply put it up here. That's all it does. It just puts it in position. I don't tell it where to go, so it just goes into the upper left-hand corner. Okay, that's what it does automatically. And that's all there is to it. The program is pretty simple. It's /body and /HTML. So that part's done. Okay. So basically what happens is the program opens up, it puts that picture there, and it bounces up to this function and starts making that picture operate, starts to make it rotate, okay? Function, okay. The very first thing I have to do is explain something a little bit more than we get into. See, that's one of the problems with programming. You start off, you show something in its simplest form, and it gets a little more, there's always more to it. And the thing is that in order to show you the more to it, what I've decided to do, instead of making a bunch of caveats, like when I explain something, they say, well, in this case it does that, in that case it does, in this case it does. I just tell you to do it one way. And then later I say, well, there's a variation. We can do something a little bit different. It's easier for you to pick up on stuff that way. So basically, this thing here, this source image right here, notice I don't have a style. There's no style. It doesn't show any style, okay? But actually, invisibly, it does have a style. All things that you put up there have a style. It's just they're empty. The only reason why we put style equals, quote, you know, do something, and position absolute and all that stuff, is because we want to tell the style to do something for us. But every single image you put up there has a style, so it's built in. So, and some things are already in the style that you don't even see. They're functions that, depending on which, whether it's Google or Firefox or whoever, depending on who it is, they have different functions that are built into their styles that you can use. They're there. You just have to call on them, okay? Google has one that allows you to rotate pictures. It's built into it. Yeah, question?
Are any of the letters in the rotate animation program capitalized?
I'm sorry, one more time?
Are any of the letters in the rotate animation program function capitalized?
No, that's your own name. You just make up whatever function you want to call it. So this is just your function, okay? What I'm going to do is, what I do in the function is going to be the part that's kind of weird, but the function itself is just a function. I could call that banana, put banana over there, it'll be the same thing, okay? It's just, whenever you load, go to that function right there. The only case where that's been different so far is when we're using Chrome's, let's see, is it the synthesizer or is it the other one? But we have to put listen, when it's listening to you. You have to put the word listen, because it's specific, it goes to listen. You don't go to it, it goes to it, so it's got to know where to go. So you have to use the word listen. All these other functions we use can use any name you want, they're all yours. Because you're going to them, you can name them, okay? I hope that's okay. Okay, so the first thing I do is I say, because I do have this style that's invisible to us, I'm going to write down the entire line, then I'll explain the line after I write it, okay? I'm going to say image 1. That's that image right there. Image 1 right there. Dot style. It has a style. You don't see it, but it's there. And also, it has this weird thing. This is I got to write it carefully because if I don't, I'm just going to have to lose. It is online though. All this stuff is online. WebKit transform. It's in today's listing. WebKit transform. The W is capital W and capital T here. Trying to transform. Okay, those two guys are capitalized. Let me just write them bigger. That way you'll see that they're capped. They're capped. The WebKit big W, and this transform here is a big T. Okay, so it's all one word though. WebKit transform is a word. Okay, and then over here I say rotate. It's the name of the function. Open parentheses. This one has double quotes. I'm going to explain it in a second. You shouldn't use double quotes, but I'm using them here just because I haven't written the program like that, and I don't want to use your degrees. Plus degree. So, okay, let me explain what this thing does. It's a very peculiar thing. WebKit transform is built into Chrome. It's just one of the things that's built into it. And what it does is it allows you to actually rotate objects. It's a built-in process that allows you to rotate objects. In this case right here, I'm saying WebKit transform, and what I send it is, it's very peculiar. You send it the function you want it to do, and how much you want it to do of it. So this function right here, that's a special function. In here you can see that these two parentheses, we're sending this information, just like we do with every function, we're sending function. But what we're sending is, we're sending it a function itself. We're saying, this function says, send Google this thing called rotate, so it knows it's going to rotate something, and this is how much you want it to rotate in degrees, okay? So here's what happens. If you actually look at this, thing right here, if you actually look at it, study what you've got here, I'm going to change this to single quotes so you'll see. No, I can't. It's got to be double quotes. Sorry, it's got to be double quotes. In this case, right, it has to be double quotes. What you really have here is this word rotate. It's a word. It's a data literal. Rotate. It's a data literal. That right there. And then we say plus degrees in here. It's just like we do in our other programs. You're adding a number in there, like 40 or 60 or 30. Whatever's in degrees, you're sending it to it. So in other words, I say rotate, and then I'm saying like say it's 40. There's a 40 in degree. That's a variable. So it puts the 40 in here. And then it says plus the words degrees, so it writes the word DEG right here. And then it closes the parentheses. That should be right here. And that takes care of it. That's what it looks like to you. See if I did that. Yeah, that's what it should be. So in other words, dag this, that's just a data literal that goes in there. So this is just a word that goes in here with that parentheses. The 40 is an actual number because you have it outside the parentheses right here. And then the plus DEG is just the DEG with that thing. So what's happening is this thing right here is sending that to Google. And when it sees that, it says, oh, they want to rotate the object, this object right here. They want to rotate this object that many degrees. And that's what it does. It does it for it here.
So where would you put the closing parenthesis? Because right after transform you have two open parentheses and one closed parenthesis.
Okay, well this is an open, this is an open right here, and this is the close right here, because this thing right here.
No, you're looking at quotes, I'm looking at parentheses.
Parentheses, parentheses. These right here?
Yeah, you've got two open ones and one closed.
Yeah, I got two opens and two closes. Open, close, open, close.
No, those are quotes. I'm talking about parentheses.
Okay, open parentheses. Okay, in this case right here, yes, we need another parentheses. Good deal. Has to be over outside everything. Has to be out there.
outside the semicolon?
What?
Outside the semicolon?
Yeah. You know, they don't do it that way though. They don't do it that way. Sorry about that. How do they do this thing? This is really peculiar. Well, they don't do it that way. They do it. You put an equal sign here. I'm sorry. I'm very sorry about that. This is not the way they do it. That's how they do it right there. There's no, and this is not here. Yeah, no, big mistake, big mistake. You gotta be careful with these things. I'm glad you're asking me these questions. This is an odd thing. I mean, these guys invented this thing. They invented this thing. They said, okay, send this function right here to Google. That's the idea. And so this thing right here is a transformation. It's like a place in space that they have set aside, a style space that you don't even know about. And when you say this right here, these words, you're telling that style space, you're going to do a transformation, you're going to do something. And this over here is what you're going to do. And so that's, when you take all quotes away, that's actually what you're going to do. You're going to rotate 40 degrees. All this says is you want to send Google the word rotate in the open, that there. Then you want to send them a number, and then you want to send them the words DBG with that closed parentheses after it.
Is that the last quotation mark? Is that before the semicolon?
The last, yeah, it's before the semicolon. This is a
Okay.
operation over here, yeah.
And then
Every line in JavaScript has a semicolon at the end of it, except some lines like the if statement with its curly cues, that doesn't have a semicolon after it. But if you put one there, it wouldn't hurt, but that doesn't have one. And this one right here does not have one. That line there where you open up the function doesn't have one. But all the other lines have semicolons after them. This is just an operation. It's just like you're taking this and you're putting it in here, so that's just a semicolon type operation.
And then this is quote, so it goes quote, rotate, parentheses, quote, or does it
Yeah,
go?
see this quote, rotate this thing? That
Yeah.
whole thing is what you send them right here. You send them this thing right here.
Yeah, I understand.
Okay. And then this thing over here, so this
Oh,
quote,
okay.
that goes over there.
Okay, that makes sense.
Okay, that's what they
Alright.
get. Okay? You okay?
And it doesn't matter how many spaces between the colon or the semicolon and rotate on the next row.
Between the semicolon. Where's the semicolon?
Between the semicolon at the end there.
Well, this thing here?
Yeah, and rotate. Does it matter how many spaces there is between that?
Are you saying
Like you
underneath on one?
push enter and then do rotate.
Wait a minute. You type this right here.
Yeah,
You put a
semicolon.
At the very, very end.
Yep, and then the rotate down there.
Oh, no, this is just, all I'm doing here is showing you what this is being sent.
Oh, okay, so that's not being typed.
No, it's not a program. That's just,
Oh.
that thing right
Sorry.
there is there. That's okay. You get the idea though. I'm just
Okay.
trying to show you what goes. Because we've done this before when we say, hello, my name is Joe and all that kind of stuff. We've done the same thing. We say, hello, my name is, and then you put in a variable which says Joe or whoever you are, plus some other data. So in other words, this right here is a literal. This part's a literal. That's a real number, and that's a literal right there. It's just what you see is what you get. And what happens is when you send this thing, it goes up to Google, and it recognizes that rotate. It says, oh, that's got to rotate this object right here by 40 degrees. And by the way, it rotates this way. Okay, it rotates in that direction. It's possible they have a radian, probably RAD also, but I'm not going to use that because you guys probably don't know radians, and there's no sense getting into it. Degrees is our normal way of looking at rotations. So we'll leave it at degrees. Like you might be able to put RAD in there, I'm not sure, but I suspect they probably have done that. Anyway, so what you have now is this line right here. This is what it looks like, hopefully. Hopefully you got it right this time. Let me just back up and look. It's this style, WebKit, transform, quote on that. Okay, I guess that's right. So what happens at this point, it will rotate however many degrees there are. Well, where did it get degrees from? Where did it come from? So what you have to do is you have to have a variable with degrees in it, okay? So what you could say is, I could say degrees up here, variable. Notice I'm putting it outside of the function. There's a reason for that, because it's going to, every time it goes through this function, it's going to rotate it one more degree, or some number of degrees, okay? And in order to get it to do that, what I want to do is I want to have I want to have the counter I want the degrees to be outside of the function, so that when I make a change, it's still there. Make a change, it's still there. Make a change, it's still there. Okay. I set it to 0 to start with. Okay. Next thing is, then what I do down here, strangely, I say draw the thing. So when it draws it the first time, it's got 0 degrees in it. So it draws it in original position. It hasn't rotated at all. I'm saying draw it, turn it at 0 degrees, no degrees, so it just draws it the way it is, okay? Now, next thing you want to do is you say degrees equals degrees plus 1. And here's what happens. After it draws it, what it does is it has 1 to degrees. It puts it in degrees. So notice this becomes a 1. After the first time through, it's 0 first, and after it comes out of this function, it's going to be a 1 now, okay? Now the thing is, it doesn't actually come out of the function right away before it does one little weird thing. This is the actual, aside from this thing, which is how to make Google rotate something. This one right here is how you create that second thread. I talked about this last time, but I'm going to write that. Okay, this one's set time mode. This has got to be written exactly like this with a capital T right here. That's small s, capital T, just the T is capitalized. What is these? I'll write this till I get this right. I don't know. Rewrite things. All right, this is a variable. I'll explain it once as soon as I get this stuff in here. It was speed of 30, okay. Okay, there it is. And I believe that's all there is to it. Let me just clean this up and then we'll be done. /script /head, and that's the program. Okay, let me explain how this thing works. First of all, when you first come down through rotate animation, and you come, see, as soon as you load, you go up there, you go rotate animation, you hit this, and degrees is 0 at this point, so it goes down and says, well, rotate 0 degrees. So in other words, you don't rotate the object at all. Okay, when you hit this line right here, that object, IMG, which is on your screen right here, would normally rotate however much you tell it to. But in this case, it's a 0, and it says it's a 0, so transform it and rotate it, but it doesn't going to go anywhere. It's going to stay in the same position. If this was 30 degrees, it would go like that. In other words, whatever degrees is, it'll rotate that much whenever it hits it. Okay, so first time through, nothing. And then what you do is you add 1 to degrees. So you've added 1 to this. This becomes 1 up here. Okay? And then down here is the weird part. What this timeout thing does is it creates a second thread. It goes to another place and it says, this right here, that's in milliseconds. That's millisecond, thousandth of a second. It says, go into limbo for 30 thousandths of a second. 30 thousandths of a second, which is not very long. You go up to limbo. You don't do anything. The program keeps running. It comes through and it finishes up. But this thing's out here, lingering out here in space, and at the end of 30 milliseconds, it will immediately come back to that location. It comes back to here and starts doing it again. It comes back to the function. So in other words, what you're saying here is, set a timeout so that you can return to this function in 30 milliseconds. So what happens is it comes down, it draws a picture of the thing, and then it goes down here and it stalls for 30 milliseconds before it runs this program again. So what happens is the first time through, when it's 0, it stays in the same position. 30 milliseconds later, now this is degrees 1, it's going to go boop like that. And then it's going to stall again, and then it's going to have a 2 in there. The next time it's going to come through, it's going to go 2. And the next time it goes through, it's going to go 3, 4, and 5. So in other words, what happens is, between here and here, This thing right here sends you back to here every 30 milliseconds. Because I set speed at 30, and I put it right there. If I put 1 in there, it would come back every millisecond. If I put 300 in there, it would come back every 300 milliseconds. This is the only way in JavaScript that you can actually stall the computer to have it do something. You can use this thing right here to tell it to play music at some given time. You can have it do anything you want to, but what will happen is it'll bump into this thing and it will stall in that position. Not your program. Your program will keep running like nothing's happening. This other thread will go over here and stall, and it'll start counting off da-da-da-da-da-da-da, and at the end of the time that you tell it to wait, whatever that is, like speed, whatever you set this at, it will suddenly go back to this function and do it again, whatever, or any function that you want to go to. Does that kind of make sense? It's a little bit weird, but basically what happens is this thing right here, they only invented this in the last few years. It was a very recent invention, because they couldn't figure out how to do it. You'd have something, you didn't want to do it right away, you wanted to wait a few seconds before you did it. But the programs are so fast, they won't wait, they just keep going. So what they had to do is they had to say, what are we going to do here? So they made this other thing, and you can call it, you can say, wait over there, and when time is right, come back and do something. You come back to some function and do it, whatever it is, okay? And so that's how this thing here works. Basically what it does is, every 30 milliseconds, it comes back, and in degrees, you're adding 1 to it every time. That's why I put degrees out here, because when I add 1, I want it to stay there. If I had put variable degrees inside this function, it would go to 0 every time, and it just wouldn't move at all. So you had to put the degrees outside. There's 2 things that have to be outside. The speed has to be outside. That could be inside, but better leave it out because for other reasons we don't want to put it inside. Other programs will want it outside. So let's just get used to that. Put the speed outside here and put the degrees outside. And so what happens, and you'll see this thing go boop, 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 and it'll just keep rolling along. It doesn't chatter though, because 30 milliseconds is so short. By the time your eyes adjust to it, it's in the next position. So it just wrote, it's just like any. Well, 30 milliseconds is very short, as you know. It's 30 parts out of 1,000. It's a very, very short amount of time. Okay. That's about as fast. And if you get down, you can use the speed of 1. The lower the number, the faster it goes. That's this. How long do I wait between showing you the next frame? Is all we're saying. And so the shorter that period, the faster everything's going to go for you. And that's a basic rotation program. That'll cause the object, whatever picture you have in here, could be any picture you want, to rotate in a positive direction. If you wanted to go in the negative direction, all you'd have to do is go right here. That's it. And then it would rotate negative this way. So if you add 1 to it, keep adding 1 to it, it'll go bigger and bigger and bigger. You subtract 1 further, it'll go smaller, smaller, smaller. In degrees, it goes as far as you want. You can go to 360, but it can keep going too. It just keeps going. No matter, it calculates where it should be. So in other words, it knows when it's reached 0, it just keeps going backwards. It keeps going backwards as much as you want to go. Okay. So does that look pretty logical to anybody? Let's try it.
I just tried it, but I realized that my image was way too big, so I just opened it up to this giant window.
Oh yeah. It works though. It's rotating. So that's actually very handy, because if you have things on the screen, there are times when you do want to rotate stuff for various reasons. Okay. I'm just going to anticipate some things here. You can actually tell it to rotate verbally, of course, because it will listen to you, and you can do an index of, and you can find out if you say left or right, you can go left or right, whichever you want. And it won't stop. It will just keep going until you write a program instruction that says stop. You can tell it to stop, but you have to do that intentionally. In other words, we have something here which just goes on infinitely, just keeps going on. You can say rotate left, it'll rotate left. You can say to rotate right, it'll rotate right. You can say stop, you can do anything you want. You just simply have to write the program so that it actually listens to you and tells the wheel what to do when you want to do it. That requires some if statements and stuff. In the next program, I'm going to do an if statement. Where am I? So I got here. There's a program called Dusty, D-U-S-T-Y.html. If you guys have your computers, that's the one for the homework assignment. Now before I get off this topic, let me talk about it. Okay. Well, the way Dusty works is I just simply have this big picture of a bunch of airplanes coming towards the camera. I don't exactly know what it looks like, but in this plane right here, these guys have propellers, or this ought to look like they're spinning or something. This guy here doesn't have a propeller, so what he did is I put a propeller on him. The way I did it was, I put the picture in the background of all the 3 airplanes, and then I put the propeller up front here, and I said, propeller spin, just like I did here. I just made the propeller spin. So all it simply does is, in the original layer, where you normally have the pictures, layer 0, Z index 0, the picture's there. But this is like Z index 1 or 2 or something, it comes forward. And so when you tell it to spin, it's going to be visibly disconnected from the background. You're going to see this propeller spinning. So it looks like, and what you have to do is, which is the next program we have to cover, is how to get the propeller that's spinning to the right place in front of this plane from the top and from the left. You've got to get it to the right place in order to run it, in order to make it work, okay? So that means you have to put it in the correct position, right? So what I want to do is, I'm going to write a program now, which is not this one, to move an object on the screen. You're going to be able to move from left to right, you know, up and down and so forth, but not the way we did it last time. The way we did it last time was we pressed the button and it just moved a little bit, got stuttery and stopped and everything. This is going to be a smooth move, just like the rotation of the propeller. It's going to move it smoothly, 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 whichever direction you want to go in, because we have the same command to work with, which is that long line of code right there. So first of all, do I have any questions about any of this so far? Any of it seem weird? Yeah. Go ahead.
So all you have to do to replace the image is put an image in your folder and then
Call it that.
call it that?
Yeah, that's where the picture is. Oh, you mean the background image?
No. So like if I don't have that particular image, I can replace it with another image, right?
Yeah, just put it right here.
Okay.
Just that, that's all you have to change is that right there. Name the new image.
All right.
Because at the source it says what image are you using to do this job. That's all you say. Okay. Okay, let's do one now where this is a simple program. With a simple program, you start this program off, and when you press a button, this arrow starts moving across the screen smoothly. Okay. It's just a simple little program. By the way, these are, as I say, these are all online, and you can take a look at them. I'll leave this here, and I'll just try some new stuff here. This program. Okay, what this program's going to do is this. You're going to see screen. You're going to see an arrow here, like so. And you're going to have a button right here that you press. When you press that button, this arrow will start to move in that direction smoothly. That's all this program does. It's a very simple line program. Well, what it does is it shows you how to get the thing to move and how to use the set timeout to keep it moving so slowly. Okay. So let's write the program. This is a button right here. It's a button. When you press it, it's going to start moving. Okay, start off with let me start with this part over here, the body. And I don't have to have an on-load this time because we have a button that starts the thing moving. I press the button, then it will move. Okay, so you're controlling the startup. If I put an on-load here, I'd have the arrow start moving right away. I wouldn't need a button. I'm putting a button here so we can say start the arrow's moving. So I don't have it automatically on. Okay, first thing I'm going to do is this button. Value space here. Move arrow. Okay. And then you have to say you have to have an on click. And we want to go to this function here. I call it move arrow. Move arrow. So it's a function. by the way, that this is called move arrow, and that this says move arrow right here. That doesn't affect anything. This right here is just text. It's just text, and it's not a variable. It won't affect. JavaScript doesn't care what you write in there. Okay, so that's not going to be a problem. Well, the fact that this is the same word as that is not going to affect anything. Okay, there's no space here anyway. This is the name of the function. If this was something like that JavaScript used, like input or something like that, some weird word that they use, then it would be trouble. Remember, these are reserved words they have. I always use words. JavaScript's not going to use these words. Okay, on click equals. We want to go to that thing right there, which is move arrow. We don't have to send it anything. Oops. We have to put it as a function. That'll do it. Okay, and the image, I got to have the image of the arrow right here. So I say image, img, and I called it the source. In my program, I have a red arrow that I saved, and I called it left arrow. That's just the name of my, it's pink. And the reason why it's pink is I don't want the background, I don't want the frame to move too, so I get rid of the frame and make it invisible. And then I put a style right here. Let me write it down here. Style equals. The reason why I have to go style is because I want to put the arrow in an original position. I want to put it in a certain spot. And then I'm going to have it stop moving from that spot. Okay, I'll say move a little bit to the right, move a little bit to the left, or whatever. But I want to have it in a spot. Okay, so I choose the spot. I say position's absolute. You have to do that when you're going to put something in a spot. Colon absolute. Semicolon. And I put it left 570, colon 570, semicolon, and then I put it at top 512. 512, that's the end of the story, I believe, yes. And there we go. Okay, so here's what happens. I have this arrow in my folder. It's called left arrow.paint. I say take that picture and position it absolutely left 570 and down 512. So it goes, it sits right there on the screen. That's the position on the screen where it goes. And that's the starting position. Okay, that's where it begins. Okay. Next thing I want to do is I want to have a variable up here that's the same as that left right there, so that when I change that variable, I can say, make the one down there the same. Okay, I'll explain it as I do it. So I'm going to make a variable right here. Variable. And I call it the x location equals, and I give it the exact same value as this. The exact same as that. They both have to set the same value, 570. Semicolon. And then I'm going to make a speed variable. Variable speed, because this thing is going to be moving. And I need to have 30 milliseconds again. I use 30 again. There it is. So basically what I have is I have a variable x location is 570. That tells me where the arrow is to the left or right. And then the next variable says this is how fast I want to move the arrow. Every 30 milliseconds it will make a little move like that. Okay. So the function itself, x location equals x location plus 1. What that does is, when it hits this thing right here, that's x location plus 1, what that simply does is, every time I hit this line right here, okay, that variable 570 becomes 571, 572, 573, it just keeps getting bigger. So every time I hit this move arrow, come down and add 1 to x location increases by 1 every time. And once I increase it, then I say, okay, put the arrow in this new position right here. I want to put it in this position. So what I say is, the arrow whose name is Ah, I wrote something out. Yes, I did. ID should be right here, equals, what do they call it? Arrow. Now, the reason why you have to have that ID is because otherwise you won't know what style sheet you're trying to change. So you have to say, it's called arrow. So therefore I want to take the arrow object, which is this image right here, that's called arrow now. We ID'd it as arrow. And I want to go to its style sheet. And I want to go to its left. And I want to change that to xlog. Like so. I think that's all there is to it. Oh, I got to set timeout, okay. So then I say set timeout. This is the same things we did before, okay. And this time I want to go back to move arrow. On speed. And that's it. End of story. So here's what happens. Program starts off. The arrow was originally placed at this position right here, 570 and 512 down right here. And above it, you have a button that says move arrow on it. That's what it says on the button. When you click that button, it jumps up to move arrow's function. And when it gets up here, the first thing it does is it says, whatever X location is, which originally was the same as where it's located, add 1 to it and put it in X location. So now you got 571 in there. And then what you do is you say, put the 571 down here. Bunk. And that thing moves, the arrow moves, 1 click to the right. And then it says, okay, wait 30, because the speed says 30 right there. Wait 30 milliseconds, and then come back into the function and do it again. So now it sees the 571 and adds 1 to its 572 now, which goes in here. Then it moves the arrow to position 572. So it moves a little bit, another click. And so essentially all it does is, when you press that button, the arrow just starts drifting right off the screen, never stops, it goes on forever. Simple as could be. But,
2 questions. Is that XLOC?
where XLOC. X location.
Oh, okay, so it's...
Xlock, Xlock,
Okay.
Xlock, yeah.
And then, for set timeout, does that...
Capital T, that's the only capital, is that T right there.
Okay. And that has to be capitalized.
Yeah, that's why I exaggerated it, so you said that's the only one. Okay. And this thing right here has to be the same expression as this, because you want to come back into the same function. Whatever the function name is here is what you normally put here. That's the one you want to wait and then come back to it again. And as a rule of thumb, any variables that you assume are going to keep increasing or anything like that, always put them outside so that they don't go back to 0 after you leave the function. If they're left outside, whatever you change it to, it stays that way. When you come back, they're still that way, and that's what you want to do. Okay. So in this case right here, this program here is kind of cool. It basically is just, it tells you how to move. And you can see immediately when you run this program, you look at it, you see what it does. You can see how it kind of works, what it's kind of doing. And once you see that, then you can start thinking about other problems that when you're going to build a program that's more complex. For example, one that you want to tell it to go this way, then go that way, then go this way, then go that way. How far do you want it to go, and all that stuff. It gets a little bit more complicated, okay? But this is the basic approach to the thing. Okay. Now, I have a program on there. Does everybody get this so far? Is it? Can we kind of erase it, or do you want? Who's working on it? Anybody? You okay? Okay, what I did is, it's hard to, I don't want to write programs for you, but I think what we should do is this. I think the strategy I'm going to take is to have you in all the assignments look at a program that we have that runs and look at how it actually works, and then just copy the parts that you want and put in your own stuff to make it work your way. In other words, that way you can sort of step into programming without having to actually invent anything. You kind of like see it work and you try it out, and when you want to invent something, you can do it, because once you've figured out how to make it work for you, and that's usually the way it works. I'll tell you, my favorite technique online is if I want to write something really strange I've never written before, I go online and look around and see if anybody else has written it. If they have, I grab the parts of it that I want, and I just figure out something, use it for my own thing. So basically what happens then is you have the access to all the programs in the world, basically to find out something that you want to write. And even though what they wrote isn't going to be like what you want, it's going to have enough of the substance to it so you can see what the real complicated part is, and you can figure out how to deal your own part within that. So if they give you the hard part, then you figure out your part that goes on top of that. And that's basically that's a good way to write. It's because if you're gonna try to invent every program yourself, you're gonna be spending a lot of time writing programs, which in regular CS courses they have to do. They start from scratch. They have to write the entire program themselves to try to figure out where they're at. I like to think about it like this. I always look at the screen first to see what they're going to see. What are they going to see? What do I have to do to make that happen? Then I start thinking about how to make JavaScript do its job because I know what I want it to do. And that's a good way to start. Think of the front page first, and then go to the JavaScript and figure out how to make that front page operate that way. If you look online, you'll see a program that looks like this. There's some kind of thing looks like that. And then there's a piston sort of thing in here. And the piston moves back and forth, like so. And it moves very slowly back and forth. It goes, okay? And then there's another mechanism where there's a wheel, like a complicated wheel. It's got a bunch of stuff on it, and it starts to roll, okay? So the whole principle, you can see the idea. If you can connect these two things together, as this piston goes back and forth, that wheel goes around, okay? Well, we can't do that yet because we can't make that, believe it or not, the only thing we can't make yet is that line right there, and it's very hard to do. But we can make the piston go back and forth, and we can put the wheel over here so the wheel turns properly. Now here's what happens. As watch my right hand and my left hand. As this thing goes this way, it goes like that. And then when it comes this way, it goes like that. Then when I go this way, it goes like that. And when I go this way, it goes like that. You can see the principle. As this thing moves, each little thing, this has to move some amount. In other words, it has to move the same. If this moves a little bit, this has to move appropriately. So, for example, if it takes 100 steps from here to here, it's going to have to take 100 rotations from here to here. It's going to have to go that far. Okay? If you do it in degrees, it won't work because 100 degrees isn't half a circle. So the problem becomes when you're trying to coordinate two animated things that are not related in a very simple way. This has got a rotation to it, and this one has a linear motion to it. You have to do a little bit of arithmetic. You have to figure out how to do it. Okay? I'm not going to do that today. I don't have enough time. But basically, what I want to do is there's a certain rule that you should know, and it applies in chemistry and math and statistics and every single thing there is in the entire world. It always works the same way. And it looks like this. Supposing I want to change Canadian money to American money, okay? And I say 1 American dollar equals, how much Canadian is that equal, you know? 22 cents? What is it? What is the equivalent? You get more Canadian money or less?
Less, I think.
Less?
The Canadian dollar's lower than the American dollar.
So it's like 85 cents, we'll say?
Something.
Let's say if that's true. Let's see if that's true. I don't think it's true. I don't think it's true, but I'll go with it. I'm going to say it's $1 American equals 85 cents in Canadian, okay? Now, supposing I give you 50 American dollars, 50 American dollars, okay? And I say to you, translate that into Canadian. Well, you have to figure out what goes where and what goes here and what goes there, okay? There's a very, very simple way of doing it. You always should remember this is the easiest way to do it, okay? Now, this is American money right here, okay? So what you do is, I can take this and divide it into that, or I can take this and divide it into this, okay? What you should always do is make sure the Americans is in the denominator, like this. I divide this by 1A, I divide this by 1A like so. This becomes 1 over here, that becomes this. That thing is what you multiply by this, 0.85C over 1A. And here's the reason why. When you think about it, it's a very simple idea, is the American, the A's cancel, and all you have left is Canadian. In other words, the units of measure cancel, and it leaves you with just one of the units of measure. So in other words, if I wanted to go the other way, supposing I had Canadian money, let's go back again. One American equals 85 Canadian. Supposing I had $50 in Canadian money, okay? In this case, I want the Canada to be in the denominator, so it'll cancel. So I multiply it by $1 American dollar over 0.85 Canadians. The C's cancel, and when you do that arithmetic right there, 0.85 into 50, you're going to get the right answer. So in other words, whenever you have to convert between any two things, not temperature, because temperature starts at a different zero, but all things like changing money exchange, that's a pretty common one. If you change centimeters to inches, for example, this 2.54 centimeters equals 1 inch, like so. If I had 8 centimeters, and I wanted to change them into inches, I make sure that's in the denominator. So I multiply that by 1 inch over 2.54 centimeters. The reason why is because the centimeters then cancel, and all I have left is inches, and that's what I want. I'm leaving centimeters and going to inches, okay? Now that idea is kind of a mathy kind of idea, but it isn't. It's really just conversion between two different things, and that's the best way to do it. Because once you get that straight, this problem right here, which is linear distance, a certain distance you're traveling, it's 200 units, 100 this way and 100 back, you can then make this thing go 200 units around, even though it's going 360. You can make it go, because you know 360 degrees equals 200 units of these units right here. Same conversion, same thing. 360 degrees equals 200 of these units, whatever they are, That's the formula right there. That's exactly true. You want it to go around once, well, this will make a complete trip back and forth, 100 points this way and 100 points that way. So the question is, how much do you rotate? You know this is going 1, 1, 1, 1, 1. How much do you rotate the circle? How many degrees do you rotate the circle to make it work? Well, it's very simple, because you want to get rid of degrees and you want to turn it into units. So what you do is, you divide 200 by 360. Can't give you that problem yet. Sorry, can't tell you how to do that yet. We got to do a little more work. But basically, that's the idea. Then we'll work out how to make that happen. I'm not going to spend a lot of time on mathy stuff, but this particular thing, converting from one thing to another, comes up in almost everywhere. It comes up all over the place. And so the thing to do is to have a way of looking at it, so you can say, I can convert this into that. If I just know how many of these equal how many of those, I can immediately do a multiplication and get the answer right away, because it always works the same way. And we'll have to use that with this cylinder thing. I think we should go to the online. I'm going to make a video online, but right now I'm going to do a little discussion of it by talking about the videos as I've shown to you. But essentially, what I want you to do is realize that this tool right here can be used for any. I made a machine out of it. It doesn't have to be a machine. It can be a bird flapping its wings. It can be anything you want to put there, a gymnast spinning or anything. The next homework assignment, which I haven't put up yet, is going to require you to do something that spins, very much like the airplane propeller on the background. Only it's going to be your own stuff, whatever it is. And that means you've got to go through a couple of stages. You've got to get used to what's in front of what. You've got to be able to put it out in the right position where it's going to be. And I don't care what it is, whether it's a gymnast spinning or a Ferris wheel or whatever you want to pick. And then what happens is your thing is going to spin, and it should spin at kind of an appropriate speed too. You don't want to. You may want to change the word speed to make it go faster or slower, whatever you want to do. And so what you do is you take the Dusty program, which has got the exact same kind of idea, and replace the things with the things you want to do, whatever you pick. But you've got to go through the process of making an invisible background so that the object is not going to have a square around it spinning. And you've got to be able to put it in the right position, X and Y, out here like so. And you have to have it rotate, and you have to have it in the different Z's. So in other words, you get experience with all of the different things as if you were writing a program, but you can just simply use the Dusty program to start off with. That'll work out. And that's what the homework assignment's going to be. I haven't put it up yet, but it's actually pretty to go. And that's it. Okay, let's do a little bit of. Don't be afraid to ask me questions when the thing is projecting, by the way, because that's what I'm trying to do is make sure that you can see how it works. And if you don't, the questions you ask are good, because then when I make a video of it, I'll be able to try to answer those questions at the same time. So give me a second to get this all up and going over here in a second.